learning target for today is I can. So you'll notice a few things that are a little bit different in how I roll, but learning target is I can find unknown measurements in similar figures. You should be on page 29 in your packet. Oh. Oh, yeah, it's still recording. Okay. Okay, here we go. So our definitions, we have two definitions here on the left. We have the word congruent. If you remember from elementary school, you should have heard the word congruent before. It means that you have two figures that are essentially exactly the same. So same what? Size. Good. Same size and same shape. Excellent. Same size, same shape. So write those words in. Same size, same shape, congruent figures. Okay, so similar. The other similar. We have a big figure. When it's reduced to something smaller, they are similar. So what you should have remembered from elementary school is that they are the same shape, but the difference is the what? Size. The size. Good. So we have the same shape. The difference is the size. Same shape, different size. Okay, so we're going to use these ideas today. The only thing we're going to hit today is this section here on similar figures. Congruent doesn't really make sense for us to do because when you have two figures that are congruent, their side lengths are all the same. So we wouldn't really be finding any unknown values. But this is the piece that we'll hit. Similar figures, two different figures, or figures that are the same shape but a different size. Steps for today. You will like this if you felt like cross products and t-tables were good for you, hand method, all that stuff that we did yesterday. If that's solid, today's lesson will be absolutely, you'll find it easy actually, because we don't have word problems today. Step one is going to be that you're going to make a t-table. Step one, make a t-table. So go ahead and write. Everybody should be writing where it says number 1, make a t-table. After you do that t-table, you're going to go ahead and grab that variable and take cross products, and the hand method kicks in at that point. Cross products, hand method. That should be a-okay for you. And then step 3 is that we will just make sure that everything looks good by checking. So you should be writing those 3 steps in. It's really more like 4 steps, but I tried to condense your writing because that hand method is involved in all that. As I said, I think you will think this lesson is okay with similar figures. So in this space over here, example 1, we're going to go ahead and do those 3 steps as described. I teach this a little bit different where I have you always label when you have 2 figures that are similar. So they're the same shape, but they're a different size. I always have you label as one of them as small and one of them as big. So go ahead and take a peek at those. You should be able to eyeball which one is small and which one's big. I'm going to give this my small and the one on the right my big because of just simply looking at the side lengths. So the t-table relationship then would be small triangle compared to the big triangle. And we're rolling right to a t-table, cross product, hand method, words locked in. So in that small figure, then we have a side length here of 6 and another side length of 8. So in the small figure, we have 2 values, 6 and 8 are the sides. All of that stuff goes on the left-hand side. What's up, Tom?
How do we know which number to go on top of it?
Doesn't matter. No, because we're going to cross them anyway. Yep. So we next have this terminology called corresponding. Corresponding, hopefully you heard in 6th grade, it means it's in the same position. So you have a 6 in the small is in the same position as a 9 in the big. So a 6 in small is in the same position as 9 in big. 6 and 9, same spot. It's called corresponding parts. Hopefully you recall that. Over here then, 8 is in the same position as X. 8 and X in the same position. Questions on where we got those numbers from, the setup, corresponding, Antoine?
Would it matter if you put like the 6 on the bottom and the 9 on the bottom? No.
No. As long as the 8 and X go with it, we're good. Cross products kicks in. So we grab our variable X, multiply on that diagonal, we get 6 times X. So working on that other diagonal then, we have 9 times 8. So we go 9 times 8. If you haven't picked up a calculator today, go ahead and grab that immediately so that you're ready to roll. We have 9 times 8 on that right, which is 72. As you know from the hand method then, our job is to get the variable x alone. This is a multiplication problem. To undo the multiplication, we will divide by 6. Copy, paste. We end up with 1x equals, on the right-hand side, then you have 72 divided by 6. 72 divided by 6 is 12 meters. So that unknown value, that x value is 12 meters, doing exactly what we did yesterday, but with similar figures. Yes, Dana?
I'm doing the same thing as we did, like we've been doing, but with shape.
Yes, exactly. We'll grab a couple real world problems as we go, but yes. Example 2. Example 2 is a little bit different because of the orientation of the triangles. The word orientation in math means the direction that the triangles are in. These triangles are not in same orientation. One of the triangles has been kicked over, the one on the left. It doesn't matter. We can still cross product it, but we have to visualize what's going on. So the triangle on the left, I would go ahead and describe it as the big triangle. The triangle on the right, that is the small triangle. In our T table, we have a big being compared to the small. Big compared to small. Now, because the orientation or the triangle's tipped over, we have to go ahead and eyeball what we call corresponding parts. Parts that are in the same position. So this x, so let's go ahead and actually fill in the big table first. In the big triangle, we have 2 values. We have an x and we have a 9. The question earlier was, does it matter which one goes on top? No. But now that we're going to start matching them, it matters. The x and 9 can go wherever you want to put them. The x is in the same position as, now what you have to eyeball this and think of the orientation. The x is in the same spot as actually the 8. So if we were to reorient or set this triangle, the big triangle upright, the x and 8 are in the same spot. So x in the big is in the same spot as the 8 in the small. The 9 in the big is in the same spot as the 5 in the small if we were to set it upright. Hand method kicks in right now. Grab that variable x, multiply that diagonal. That becomes 5 times x equals, multiply that other diagonal, 8 times 9. 9 times 8 or 8 times 9 is 72. Hand method. So we're going to undo that multiplication by division. Divide by 5, divide by 5. Copy, paste. We end up with 1x equals, we have 72 divided by 5 is 14.4. We don't know the units in this particular problem because it doesn't say feet, yards, miles. So we're just going to say 14.4 is this x value here, 14.4. Okay, so this is the idea of similar figures. You have 2 figures. They might not always be facing the same orientation. So you're going to have to adjust with your eyes and find the unknown. Let's do a real world problem. 100% chance you're going to see something like this on the MCA test. A flagpole with a shadow and a man and something like that is going to happen for sure. So here's our first example. I want you to visualize that we have the sun shining out here, creating this shadow. And you've all probably have been in a situation before where you've seen your shadow, you try to step on your shadow, right? Or it
doesn't work. Yeah.
So, and that's all about angles. But what we can do in this problem is we can find the height. It's kind of some cool math involved here. You can find the height of this flagpole, x, without ever climbing the flagpole. What all you would need to do is, first of all, you would need 3 things, 3 values, and then your unknown x in a proportional situation. So here's how it would work. We have this big triangle. I'm going to call this my big triangle. And then we have this small triangle over here. We have these 2 shadows created. We have a shadow from the flagpole, but easily we can measure the length of a shadow. Just run a tape measure on the ground. We could also easily measure the length of the shadow of a man. So we have the big figure compared to the small figure. In the big figure, we have an x and we have a 28. We have an x and we have a 28 in the big figure. X and 28. The x is in the same position as the 5. So the height of the flagpole is in the same position as the height of the man. So the X and the 5 go in the same line, or in the same spots. X in the big is in the same spot as the 5 in the small. I hope we're feeling okay with that. In the other spot, the 28 is in the same position as the 4 in the man. So the two shadows are in the same spot. Taking cross products. Grab the variable X. Multiply the diagonal. We have 4 times X. Over on the other diagonal, then we have 28 times 5. So everybody should be multiplying 28 times 5, 4, 5 times 28. And we get 140. Hand method kicks in. Divide by 4, copy, paste. We get 1. X equals, on the right-hand side, we have 140 divided by 4. And the value is 35. The unit would be feet. So the beauty is we are able to find the height of this flagpole of 35 feet without ever having to climb the flagpole, which would be dangerous. So that's example of a flagpole that's gonna be on the MCA test for sure. Something like that. Yeah. How do you feel about that? Okay. Let's take a look at this other problem over here. Kind of similar in style. I want you to be very careful about this problem though. This is one of the tricky problems I think in this homework section. So there is a small triangle here. I think you're okay with it. It has a base of 3. It has a height of 4. You probably can see that just fine. What is tricky is that there is also a large triangle. It has, this is the base. So let me show you that again. The base of the large triangle is all of this. So it's really 3 plus 8. What's the base of the large triangle? It's actually 11 feet. Good. It's asking us what is the height of the tree. We don't know the height of the tree. So let's get that set up. Oh, I misspoke here. This should have been the small triangle. Sorry about that. This should have been the small triangle. And then this here, you can see that it overlaps a little bit, is actually my big triangle. So we have a small triangle, big triangle. This one is not as easy because of the overlap. But once you solve one of them, you should feel pretty good about it. In the small triangle, then I have a 3 as the base and a 4 as the height. So I'm going to put those two numbers in my table. It doesn't matter which one's on top. But now that they're in, we have to correspond our parts. The 3 in the small. The 3 here is the same as the base of the big. The total base of the big we just decided was 8. I'm sorry, 11. The 3 in the small is the same as 11 in the big. So the base of the small is 3. The base of the big is 11. The unknown value then, of course, is x. We're trying to find the height of the tree. Taking cross products. Grab the variable x. Multiply the diagonal. So we have 3 times x equals. Multiplying the other diagonal, that's 4 times 11 is 44. Hand method kicks in, we divide by 3. Copy, paste. We get 1x equals, we have 44 divided by 3. 44 divided by 3 is 14.6. If we round to the nearest hundredth, it's a 66666. So 14.67 unit is feet. The height of this tree is 14.67 feet. Questions on how to find the height of a tree using cross products, 14.67 feet. Okay, meet me on the top of the next page. Top of the next page, it should say Volkman Boys Example. I'm going to show you a picture of my kids when they were little. We're going to talk about when you take a photo and you shrink it or you enlarge it. So we reduce or we enlarge photos all the time. So here's a picture when they were, I think it was Nate, my oldest son's first day of school. So my oldest son Nate and my youngest son Matthew, this is I think his first day of kindergarten. I need some more space here, so I'm going to make these a little bit smaller. So we're going to say that I'm going to maybe make this into wallet size. So this is the original photo I printed. And I like the photo so much, let's say that I'm going to put them into wallet size. We're going to reduce it. The directions down here say that, I'll change that background for you so it's a little bit easier to see the writing on it. So the original photo has dimensions of 11 inches wide. So you don't have that on your screen or on your paper, obviously. So I'll do all the writing up here for us. That's 11 inches wide by 8.5 inches high. So this is 8.5 inches. So I made a pretty big picture. Like it would be the size of like if your parents have a big picture of you in your, you know, like that 8 by 11 picture that most people get of your school picture. That's the equivalent picture, we'll say. I'm going to shrink that down to a wallet size. And when I do that, what I know so for sure is that the height of my new picture is 2 inches. So this new photo has a height of 2 inches. But what I don't know is the width of it. T-table cross products. So here we go. We have a big photo here. Just wrote on my kid's face. A big photo here and a small photo here. So we have a big and a small. Go, 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 go. Everybody's setting up T-table cross products. Working hard. Let's go. T-table cross products. Yep. Okay, I'm going to start to solve. I know you're trying to catch up here, but the 11 in the big photo, and there's an 8.5 in the big photo. Now it's super duper important that you put things in the right spot. These two, it doesn't make any difference. But once they're in, this is crucial. The 11 is in the same spot as the W. You could have an X. Some of you might be using an X, but 11 and W are in the same spot. The 8.5 is in the same spot as the 2. Taking cross products and solving, then grab the variable W, multiply the diagonal. So we have 8.5W, multiply the other cross product is 22. Hand method kicks in, divide by 8.5, copy, paste. We have 1W equals, we have 22 divided by 8.5 gives me 2.59 inches. So as I change that photo now has a width of 2.59 inches. Questions on that? Super real world question that you have to be able to solve. Okay. The next, what does the next box say? Oh! It does, huh? That's me, in case you're wondering. So if you've been to my website, this is the picture that you'll see. Ms. Gorman took this picture for me. So this was the original size of the photo, and because it's so super amazing, I decided I'm going to make it into a wall size of me. And I'm going to put it in my classroom next year. It's going to be fabulous. So, Dana's like, really, Ms. Gorman? Here's the deal. So yeah, that's right. We are going to take the original photo. Most photos when printed are 4x6 in size. So like this is a 4x6 photo that you're kind of used to. I'm going to enlarge it. So as I look at the original photo, it says that the height of the original photo is 4 inches. So the height of the original photo is 4 inches. And you don't have to write any of that down. The width of the original photo is 6 inches. So you're just kind of watching what's going on until we get the setup. As I continue to read, it says that the width has been enlarged to a width of 10 inches. So 10 inches is my new width. What is the new height? Our unknown then is, what is this? Cross product solve. Go. Everybody solve. Cross product solve. In the small photo, we have a number 6 and 4. Line them up. In the small photo, we have a 6 lined up with a 10. So 6 and 10 are in the same spot. We have a 4 lined up with an X. So 4 and X are in the same spot. Cross product. So here we go. We grab the variable X. We multiply times 6. That gives us 6 times X equals. Multiplying that other diagonal of 4 times 10 is 40. Hand method kicks in. Hand method kicks in. Divide by 6, copy, paste. We end up getting 1x equals 40 divided by 6. We get 6.6. That's a repeating decimal. 66666. We should really round that to the nearest hundredth. So that's 6.67. 6.67. The unit on that would be inches. So we've changed the height to 6.67 inches, which is really a half foot tall. Okay, moving on. What's the next box say?
Lighthouse.
Lighthouse. Lighthouse. You're going to go ahead and find the height of that lighthouse. Go. Everybody's working. Find height of lighthouse. I know it. Here we go. Find height of lighthouse. The big and the small. Find unknown parts. Cross parts. So you should have that the 8 and the X, I know some of you are still solving, but I'm going to start going. 8 and X are in the same spot. And the 2.5, the base of the lighthouse is in the same position as the base of the big lighthouse. Cross products and solving, we're going to grab the variable X, multiply that diagonal. That gives us 2.5. X equals, multiplying that other diagonal, that's 8 times 10 or 10 times 8. Community property allows us to flip that, which is 80. Hand method kicks in. We divide by 2.5, copy, paste. So here we go. We're solving for that variable X. Divide by 2.5, copy, paste. We get 1x equals, that's 80. Divide by 2.5 is 32. And we don't know the units here because it's not labeled. I assume feet, but it doesn't say. So we're just going to lock in at 32, the lighthouse problem. So we're doing most of our work together today, so you don't have as much to do on your own. And the next box says what?
Car.
Car. I would like you to take a look at these two cars. Our job is to find the height of that car. Go. Everybody's working. Height of the car. Height of car. Height of car. Get big, get small. In the small, you have a 3 and you have a 5. Those are the two dimensions. They can go in either way in the table, but once they're in, you are locked for the rest of the problem. That 3, the height of the car is in the same spot as the X. So the 3 in the small is in the same spot as the X in the big. So they're going to go in as corresponding same position. That means that they're written in the same spots. The 5, the width of the car is in the same position as the width of the small car is in the same position as the width of the big car. So 5 and 12, lock in. Grab that variable x, hand method kicks in, that's 5 times x, equals 36, multiplying that other diagonal. Divide by 5, copy, paste, we have 1, x equals 7.2. Again, that's the height of the car. We assume feet, but the units aren't there, so we can't really lock in at any value. We have one more problem like that. Then we have one problem that I need to talk to you about, and then I'm letting you loose for the rest of the way. Here we go. The next problem is the palm tree example, I believe. I'd like you to find the height of the palm tree. Very, very similar to the flag example. Oops, that's not the screen I wanted you to. Sorry about that. I still want you to find the height of, there's way to go, movement. Still want you to find the height of the palm tree. Visualizing that if you had a sun out here, you would be creating these shadows. Hopefully you can understand that based on the, like, this shadow happens. And so you get this big triangle and this small triangle because of the shadows that the sun creates. I'm going to just start setting some things up while you guys are working. Taking cross products and solving in the big triangle then. In the big triangle, we have an x and we have a 10. Again, they can go in either spot, but once you're in, they are locked the rest of the way. So I have mine in. I have to keep them now. The x is in the same position. So we're really talking about the height in the big has to be in the same position as the height in the small. So the x and the 6 go in the same spot because they're corresponding parts. The 10 in this big has to go in the same spot as the 2 in the small. Cross products and solving. Most of you can mental math this, but I still, because of the learning standard, I need you to go cross products, hand method on all of it. Grab that variable x, multiply the diagonal. We have 2 times x equals, multiplying the other diagonal, we have 10 times 6, which is 60. Divide by 2, copy, paste. So we end up getting 1x equals 30. 1x equals 30, so the unit would be feet. We would say that this palm tree is 30 feet in height. Excellent. This is our last problem. The next box is our last problem of the day. Together as a group. In this problem, I have to find it first because I'm on a different slide than you are, so give me a second here. So you should have covered all those boxes. So we're in this box that says the ratio of their perimeters. Perimeters is distance around something. But we're really just trying to find the unknown value x. So the ratio it says is 4 to 3. Now all day long today we have been talking about a big figure compared to a small figure. And it didn't matter which one was on left and which one was right, because we're going to count them anyway. If we have a 4 being compared to a 3, which one of those would be our big? If you have a 4 compared to a 3, the 4. So that has to come from our big figure, and this has to come from our small figure. So we already have 2 of the 3 numbers. Remember in a t-table, we have 3 numbers and we have a variable and then we cross them, right? They do have to be in the right spot before we cross them. So as I continue to read, it says find the value of x. So we have an x here and we have a 12 here. So I can see that I have 3 numbers, 1, 2, 3, and I have a variable, but it's a matter of putting them in the correct location. So I am going to compare big to small. So 4 had to come from big and 3 had to come from small. So go ahead and write. Simply by the ratio, 4 is bigger than 3. So 4 had to come from the big relationship. My dilemma is what's next. I have 2 figures. I have to figure out which one of these is big and which one of these is small. Simply by eyeballing, I hope you're able to see that this is small and the one on the right is the big, just by looking at it. And maybe it's hard to see on the screen, so it might be more helpful to look in your paper to see that the one on the left should be small and the one on the right should be big. Now I have everything I need. The x should go in the small column, and the 12 should go in the big column. Taking cross products and solving. This is our last problem today, guys, together. Grab that variable x, multiply by 4. I'm going to show my work down here. We have 4 times x equals multiplying that other diagonal, we have 12 times 3, which is 36. Hand method kicks in. We divide by 4, copy, paste. We end up getting 1x equals 9. So the unknown value here is 9, using the idea that one's big and one's small. So your job then is for the rest of this hour and the rest of this day, due tomorrow, is to finish all of page 30 and all of page 1. So you should be all of page 30 and all of page 31 due tomorrow.